Hello, everybody, and welcome to another episode of Connect Conversations. Today's conversation is all about key processes for a successful PdM program. It is brought to you by a part of Mobius Connect's ongoing YouTube series, Connect Conversations. I am Kim Fugger, and I will be your moderator for today's session. First, I'd like to take a moment to introduce the host of Connect Conversations series, Global Reliability Improvement experts, Doug Plucknette and Ron Moore. Hi, guys.
Hello.
Okay, fantastic. Well, before I pass the microphone over to you guys, I want to encourage our audience here today to submit any questions that you have through your questions panel during the webinar. And as we go today, Doug and Ron will take some time out to answer all of your questions. So please just keep those questions coming in. And Doug and Ron are here to provide their advice and perspectives from their years in the industry and are here to help you. So keep in mind, they will be answering your questions live today. All right, Doug and Ron, I'm going to go ahead and pass things over to you.
Okay, and thank you. And of course, thanks to everybody that's joining us today. We appreciate you being here and hope you find the day useful. And like Kim said, if you have questions, feel free to, type them in and we'll give it a shot and try to answer them. I wanted to start off with just an observation about the phrase predictive maintenance. It's a very right. You got Doug's opinion. You're going to get mine momentarily. And I guess neither one of us particularly cares for the phrase predictive maintenance. And, I used to be the president of a predictive maintenance company, but I always had a bit of a problem with that term because it implies you can predict when something is going to fail. And that's just not really true. There's been some research around vibration to try to predict when, but it hasn't been very successful as I understand it. So you can predict that it's going to fail, but when is a much more difficult issue. And there are just so many variables there, it's really hard to do that. So I prefer the phrase condition monitoring. And, condition monitoring is much more broadly encompassing. Of course, it includes the traditional so-called predictive maintenance technologies, but it also includes operators looking at the process and the equipment condition. Operators, by the way, according to some of the studies by credible folks, can detect something on the order of 40% of the defects. So it's really important that they be a part of any condition monitoring program. And of course, routine inspections. That's a form of condition monitoring. One more comment, and I'm going to, bounce it over to Doug, and that's this. If you're going to do this, you have to have really good work management processes in order to act on your findings. Because if you don't have that, you're going to be monitoring a lot of stuff and nobody cares. It just winds up being one more, report or bit of information that nobody acts on. And then the third thing you got to do, besides having a broad-based comprehensive condition monitoring program, and then you have work management, planning and scheduling, that sort of thing. Third thing you got to do is you got to be proactive. What are you going to do to stop the defects that are occurring that you detect, but then it's too late? The equipment's already on its way south. So what can you do to either extend the life of that equipment or minimize the risk of the defects in the first place? So I'll hush now and bounce it over to Doug. Your thoughts?
Well, I've always been somebody that's really read thoroughly the RCM document written by Stan Nolan and Howard Heap, and they referred to this as on-condition maintenance, and that's probably a term I like, but I certainly like condition monitoring as well. I'm also a person that says this is a must for any maintenance organization. It doesn't really matter how large or how small. This is one of the types of maintenance that needs to become part of your routine. So we have preventive maintenance, we have on-condition maintenance, we have failure finding tasks, we have redesign, and we have run to failure. But in order for this to be effective, as Ron says, you really have to have your stuff in order in terms of workload management, right? And responding to this. I'm a person that says, if you're going to get into this, there's some key measures that you need to be involved with. And early on, companies used to say, gee, we're going to measure the amount of saves we had. Well, what are saves? Well, we've detected that this was about to fail. Okay, and then did you do anything about it? It's one thing to detect it. It's another thing to perform that corrective maintenance and repair the item before the failure occurs. And those are the important aspects of a good condition monitoring program. So I think today we're going to talk about probably at least 3 or 4 of the different technologies. And before we came on the air, Ron and I kind of chuckled that it would be easy to spend an hour on each of the technologies. But I think coming into this, what our idea was to say, gee, there's a lot of companies that are just getting into this or considering this. What are the technologies that they really should start with? And I'll pass that back to Ron.
Okay. Well, I wanted to make one more comment about, the phrase predictive maintenance. You can't predict when, but you can predict that. Now, in terms of applying, the technologies and the methods really, because it includes operators and inspections, the severity of the condition is a consideration times the consequence of failure times the rate of change, the rate of increase in the severity of the condition. If you take those 3, that will give you a priority for action. So severity, consequence, and rate of change will give you a priority for action on whatever you find and putting that in your work management system. And again, you won't be able to predict when, but if you use that criteria, you'll do a much better job managing the risk that this might turn out to be a really major failure for you. So I'll pause there unless Doug's got a comment on that particular point.
Yeah.
Okay. All right. Well, there's lots of technologies out there. Vibration, of course, is the one I'm most familiar with. Because that was CSI's long suit, as they say. Infrared is good, oil analysis, and ultrasound. And then there are other technologies, non-destructive test technologies, corrosion detection, so on and so forth. Those, reciprocating engines. There's quite a bit of technology out there. I guess my view would be the most important ones to have that'll pick up on most of your failures, unless you have a particular application like your diesel generators that are critical to function during an emergency. The vibration, oil, infrared, and ultrasound, I would submit, are probably the most important ones that you really need to have a good handle on. Needs to be comprehensive, needs to be collective under a single supervisor. Now that supervisor might not know all the details of how all the technologies apply, but they ought to know enough to know what those programs should include in order to be effective. So, Doug, any comments on that?
Speaking right back to that, that appears to be one of the weakest links of this chain when you talk about companies that struggle with condition-based maintenance or condition monitoring. Is that educational piece where managers don't fully understand what the technologies are, how they work, why they're important, and why we need to respond to them as quickly as possible when we see things in alarm. Again, it gets into the time frame. How much time do we have left? Well, I wish I knew. All right.
Yeah.
What we do have time to do is we have time to plan, we have time to schedule, we have time to complete. That's the important piece of that. So find me that window where we can do that complete piece of it. That's what I need from you. Right.
Yeah. Well, and that's a fairly common question. Well, when's it going to fail? Well, who the hell knows? So it could fail while we're standing here, if it's really severe, or hell, it might last another month. You just never know. But yeah, you ought to go ahead and consider the severity of the consequence and the rate of deterioration, and do some risk management.
So in the measure that I tell folks, the most important one is defects detected, defects corrected, right? So how many did you detect and what percentage of them did you actually correct? That's the piece that we're looking for.
Before they failed.
Right, correct. Yeah.
Or how many did you detect and then you didn't correct and they failed and it cost you a truckload of money?
There you go.
Both in terms of production and extra collateral damage and all that sort of thing. So
yeah.
Now, one thing we probably ought to discuss even before we get to particulars of some of the technologies is this so-called PF interval. The period between you detect a potential failure and you have a functional failure. Now, I think most folks out there listening are familiar with that curve, but then you get to this question of, well, how long is that PF interval? Well, that's another one of those kind of ambiguous, cloudy, fuzzy issues. It might be one day, it might be 1 year. It kind of depends on the equipment, the technology, the operating context, and a bunch of things. So it's an interesting concept, and I like the concept, but you're not going to know in a lot of cases unless you have a really good database, and you can use, I think, Weibull analysis to determine what that PF interval is and what the appropriate frequency for measuring is. Then that's going to be more of a concept than it is an actual practice. Doug, do you have any comments on that?
What I teach with that, Ron, is that, use this as a theoretical tool, right? This is that all things fit the PF curve. The big difference between one thing and the next is the amount of time it takes to get from point P to point F. And some of our electronic components, that's parts of a second, and some of our mechanical components, that can be 6 months to a year, right?
Yeah.
So you have to look at that and think about what are the different variables, right? Have we seen it before? Are we looking at the same failure mode? In fact, right? Was the first time was it actually wear based? The second time was it lack of lubrication? Those were going to give you two very different PF intervals, right, to deal with. So we have to tell people, be theoretical on that and really be disciplined in the interval at which you should be performing the task if you're not doing it continuously. So if you're doing vibration analysis on something and your route says monthly, you have to stick to that monthly interval. You can't let those things slide. That's where we get into the danger of missing defects or failures And then we actually have a failure where it goes out and totally ruins itself, and we didn't catch it with the technology. And then all of a sudden you've got people saying, oh, I don't think this really works all that well. You have to be disciplined in sticking to those schedules if you're not doing it continuously. And in today's world, more and more, we're seeing more and more continuous monitoring.
Yeah. Well, and the other thing too, just try to throw out an example. If it's a transformer, the infant mortality period might be a year and the PF interval might be a year, and I'm not an electrical guy, but I'm just, throwing some numbers out there as a guess.
Sure.
If it's a bearing, the PF interval might be, a minute or two if you didn't lubricate it and it's high speed. And, the PF interval might be something, similar. So, yeah, like you said, those are kind of theoretical things that you ought to, be concerned about. Now, anyways, anything else on that, Doug, before we muddle on?
No, let's get into the different technologies, what their uses are, what their best applications are. Because I know we're pretty limited for time on this one today.
Yeah. Well, vibration, of course, is, rotating machinery, as everybody would know. And, some of the things that come to mind, and again, I am not an expert. I'm not even a vibration analyst level 1. So, but the things that I think about are things like the frequency of inspection. Now, that frequency, and I just had another thought here, the frequency of inspection. And so this is, I'm kind of a little side comment here, sidebar, as they might say. If you're doing vibration analysis once a month, is that, data collection, is that a PM or a PDM? And if I open the mic, we'd probably get, well, half of you'd say it's a PDM because you're doing vibration analysis. The other half maybe would say it's a PM. Well, in my world, it's a PM because you're doing it once a month. It's a time-based activity. And so if that's what you're doing once a month, it's an inspection. Now you're using some fancy technology, but it's an inspection. Now, if you find a problem, the work you do after that, if you can get it done in something greater than a week from now, then I call that a condition-based activity because you found the problem, you planned it and scheduled, you got the parts, the resources, and so on, and you got it done on a very deliberate basis. If you find something and you have to work on it right now, well, that's reactive because that's disrupting all the work that you've already got planned. So that's just some, thoughts about, whether or not condition monitoring is a PM or a PDM. Most of it's PM in my world, but the work that comes out of it, which is really most of the work, is a PDM. So any comments on that, Doug? I know we keep, kind of.
I know that the SMRP community views those time-based or those scheduled tasks as PDM. And it's really, it comes down to what I tell people. Look, we can get caught up in the semantics of what we call things. What's important is if you're benchmarking with somebody else, that you make sure that you are each talking about the same thing, right? Yeah. So whether you view it the way Ron is viewing it, or you view it the way somebody else does, just make sure that you're both speaking the same language, so that when you do the benchmarking, you come to an understanding of, are we comparing apples to apples here?
Yeah.
All right.
Yeah.
So
okay.
Moving ahead with and speaking with vibration, there are lots of different applications for this, and this is where I tell companies now. there's a couple different ways to get involved with this. One of them is to train your own people, right? And that takes time and it takes money and it takes patience. They're going to make some mistakes. They're going to miss some things. They may overreact to some things. But in the end, you've got a person that, in my opinion, has a stake in your business and cares about your company and your assets. And in the end, you end up with somebody that's much stronger or a better advocate for what you're looking to accomplish. The other way to do this is to hire a company in that says, okay, we have a bunch of people that we trained and they come into your company and do specific routes, and then they send you a report. It's interesting. I've seen this transition through the years. When I first started way back at Kodak, and we had the technologies group, we had our own people, and I think it worked fabulous. They ended up with relationships with the departments that they were working with, and they become very valuable employees. Then this became popular, and it created a market for people that do that, right?
Yeah.
And they started almost job hopping, a lot of them, right? Because they had experience in something that companies needed, right? So that's kind of the danger of hiring somebody outside is, are you going to have that same person? Do they care about your company? Do they care about your assets, or do they care about, here's what I'm making an hour at this company? So those are things that they're difficult questions to answer sometimes. I'm a person that I tell companies straight up, look, if it were me and it were my company, I'd train my people and I'd pay them what they're worth, right? And keep them, right? Find somebody good and keep them.
Yeah, I've got maybe a little bit of a caveat to that, Doug. I agree with you for large companies.
Yeah.
Folks like, I guess, Kodak or DuPont or US Steel or, whoever it might be, you ought to have your own in-house resource because you're big enough to support and sustain that. And sustain being one of the key operative words. If you're small and you have very limited resources, you got, a few people multitasking, then maybe contracting it might be a better approach.
Might be the only option.
Well, it might be the only, yeah, that's right. Might be the only option. And there's probably some hybrid models in between. For example, you might be big enough to have a dedicated vibration analyst technician, but not quite big enough to have a dedicated infrared and or oil analysis or ultrasound, or you might be big enough to have vibration and ultrasound, but not quite big enough to have, some of the others. So you probably want to contract those things that you're not necessarily going to get good at, and you don't have the resource to get good at it, then it'd probably be better off to, contract that out. So that's just a couple of thoughts on that. I've got some criteria. I don't have it right in front of me for when you contract and when you don't. So, but I want to get back. We kind of got off track there. Talk a little bit about some of the technologies. And again, I'm not an expert in any of them. But for example, vibration, my recollection on vibration was if you have a good program with frequency banding, somewhere 1 times, 2 times, 3 times, and so on, and you use sufficient resolution, to get a proper reading, and you use appropriate windows. So those are some things to consider, and you use the appropriate sensor. The little used to be called a stinger, I think it is. I don't even know if those are still in use today, but you have to have a good signal coming off the machine into the accelerometer such that you get an accurate reading of what the vibration levels are. And then the other thing that's I think is really important is that typically something, at least Art Crawford said, something on the order of 80 to 90% of rotating machinery problems relate to unbalance and misalignment. So if you can resolve those and get that under control and do a proper job aligning and balancing your machines, then you've solved almost all your problems. And yeah, there are bearing fault frequencies and there's sidebands of one machine or another, and there's motor fault frequencies. And yeah, as you progress, you ought to develop some capability in those. But golly, get the basics right first. Get the tall wheat, before you go, chasing after the little grains. So that's some thoughts. Now, there's several vendors out there. I think they all do a respectable job. So at this point, I don't know enough to know which ones are good, bad, or indifferent. I just think that if you're going to run a vibration program, you've got to set up your databases properly with the machine data in your database for each machine, right? That's real important. You got to set up your routes properly. So you do your periodic inspection using vibration analysis. You got to make sure that program is tied to your work management system so you can act on it. What else? You've got to, well, try to make sure you have a reasonable analysis software and capability to keep your databases up to snuff. And there's also, your bearing fault frequencies. There's databases, or there was databases out there where you could enter all that and do a more detailed analysis of your bearings and why they failed. So those are some, I guess, initial thoughts that come to mind on a vibration analysis program. Doug, you got anything to add to that?
I'd like to keep companies from making mistakes when we talk about these things. And you mentioned that it's got to be tied to the equipment and the hierarchy. And I say, all right. And one of the ways that we make sure that we do that properly, especially when you got guys out doing routes, is the pump that they're calling 201B actually 201B, right? Are they talking about the right asset? And so I say, make sure equipment's labeled and make sure the report comes with a photograph of what they did the analysis on, which includes that equipment label, right? So that when all of a sudden something is an alarm, you're guaranteed that we're talking about the right fan, the right blower, the right pump, in the right location, so that you don't go out and work on something that doesn't need to be worked on, right? I've seen that done in the past. So I'm one person says, make sure you got your ducks in a row, especially when you're using those outside people, right, that may not know exactly what you call, the ABC delivery pump, right?
Yeah. And I had another fleeting thought there, and I just lost it. So, but they. Oh, yeah. The other thing I wanted to mention here is that at least this was the case in my history, and I suspect it's not changed very much, is that, for example, a vibration program is a really, really good one where the people are properly trained, they're properly experienced, you've got your databases and your route set up, you're doing proper frequency banding, the proper resolution, using the proper sensors, and all that's good. Those programs will generally have about a 90 to 95% success rate in identifying the fault accurately. So what does that mean? Well, that means 5 or 10% of them are going to be wrong. You you take something apart, you don't find a problem maybe 1 in 20 times, and that's for the really good programs. So these, at least vibration analysis is generally not fault free. So don't expect it to be perfect. And you probably ought to keep track. In fact, you probably will keep track of the ones where you got it wrong, so you can try to, figure out what you do next time when you got something similar, pop up. So that's just a caution to you, because I know managers say, well, we got this damn program and you guys missed it, or you guys told me it was bad and it's not. Well, dang it. Well, that's going to happen from time to time. So don't let that destroy, the value of a good, vibration analysis program. So that's, we'll pause there, and I'm going to go on to the next one. You ready for me to go?
Add one more thing on you first. So now that you've gone out, you've done your route, you found some defects. The very last step of that is to say, what was the cause?
Yeah.
All right. And that should be part of your program. Anytime that a defect is detected, a cause should be determined. Don't just go ahead and rebuild, right, without first or at some point in time saying what caused it. Because in most cases, the causes can be eliminated.
Yeah. Well, that's that proactive element that I mentioned earlier. When we were talking about a high level, program, you got to add that proactive piece to stop the defect occurring in the first place. So now infrared, what I know about infrared, you could probably put in a thimble. I do know that it's quite a good technology for detecting hot spots, cold spots, and so on. And so in my mind, at least, it becomes fairly process oriented relative to determining, not just electrical equipment, but tank levels, overheated machines, that sort of thing. One of the things that sometimes gets missed is this concept of emissivity and having the right temperature band around your equipment. So those are the kind of the biggies that I recall that we need to make sure we address, is make sure that folks are trained in terms of putting the right emissivity numbers into your system, so you correct for that, and making sure that you apply the technology appropriately. There are lots of really good, really cheap cameras out there these days, and I think in my mind there's no excuse not to have one. So then the issue becomes, are the folks using the technology, are they properly trained to properly apply the technology and get an accurate answer in terms of detecting the defects? So, Doug, do you have any comments to add to that?
It's one of my favorite technologies in terms of, I tell people that the number of uses of this continues to grow. And I'm a person, again, very early on in this, I said, I like you have your own people in-house. And even with contractors, sometimes they end up they might be a different company, but they're in-house, they're working for you. This is a grand technology for people that are curious, right? I remember a customer early on that had overhead rails for moving their products from one area to the next. And boy, they had fits at times trying to figure out which sections of this rail were worn and what was going on. And their technician actually playing around with the camera one day said, "Hey, I think I can see where the spots for the rails are getting thin with this IR camera." Right? Now, he says, afterwards, I was able to see it, but one of the things that I know is I immediately went and asked, how long has the conveyor been running? Right. He said, because if it's only been running 20 minutes, chances are you'd never see this. But if it's been running 2 or 3 hours and you got stuff going across there continuously, now you can see that. And so while we like to look at things, electric panels and steam lines and roofs and all kinds of different things, people that have that innate curiosity can discover lots of stuff with a technology like this. And that's one of the things that I like about it and always have liked about it is when you have that curious person, the boy, it becomes a real asset.
Yeah, well, I got a little more story myself. The first time I ever saw an infrared camera was at a show. And I don't remember the name of the show. It was one of those big maintenance shows where you have lots of folks demoing equipment and so on. And I remember the guy, Bill Yance, he used to work at CSI where I
I
worked.
knew Billy.
Okay. And he had a lot of enthusiasm. I said, well, Bill, show me what this thing does. And he pulls it out and he has me stand and he takes a picture of me, right? And he comes up and he says, you've had a broken nose. And, so I was really impressed that he knew I'd had a broken nose. And I said, how do you know that? And he goes to the picture. He's a little bridge right across there. He said, see that blue streak? That's where you're not getting much circulation in your nose. So it's probably been broken. Well, and he was correct.
Wow.
I boxed for a while, not very well, as you might suspect, based on my nose. But it, like you said, that goes back to the point about being curious with the technology and learning about it and being properly trained to use it. So we ought to touch a little bit. And by the way, Kim, if you're out there listening still, for whatever reason, I don't see any questions coming up. So if you see a question or if somebody's come out with a question.
Yes, thank you, Doug. To all of our participants, if you guys do have any questions, you are welcome to submit them in the chat. You can send them directly to me or to the whole group, and Doug and Ron are here to answer all of your questions.
Yeah,
they will read them anonymously, so don't feel like you're going to get called out.
Well, we won't do that. Anyways, I want to talk just a tiny bit about oil analysis. And again, I'm not an oil herbologist, level 1, 2, or 3, or oil expert. But the thing that strikes me about oil analysis at the highest level is that, at least from what I've read and observed in being around some of these plants, is that brand new oil is ISO grade crap. And, it's kind of a technical term for dirty. And, I was in a paper mill one time and they had a superb, lube analysis and lubrication program. And they had dedicated folks who looked after stuff. And on one side of this building, or, kind of not a warehouse, but, a good sized place where they kept all their lubes, they had these tags hanging off the lube, and I just walked around and it says ISO grade, 21, 20, 18, 23. And I don't know if you know what that means, but it means it's crap. ISO grade 20, means you've got as much as 10,000 wear particles per milliliter. Milliliter, about the end of your little finger. And so what they would do is they would test all the incoming oil. They would take that, they would filter it to a standard for the machines it was going to be used in. And they would put that filtered oil over into another section of this building where they would tap into that oil as needed. So, that just struck me as being, wow. Really? I wonder what's going in my car, when I saw that. And, so they had just an excellent program that matched, that understood what they had in the incoming oil, They understood the filtration process. They filtered it to a standard, ISO 15 or 13 or 11 or whatever it may be, filtered to a standard, and then kept that separated. And even in the separated area, they had filters and desiccant filters and wire particle filters on that. And they tapped it into sealed containers. The sealed containers were color coded, and then the machines had a color code on them. So you put the purple lube in the purple dot machine. So it was really hard, unless you were just doing it on purpose, really hard to make a mistake, make an error when you were doing that. And the folks were trained as, proper tribologists, not just grease monkeys. So those are, that's the sort of thing you need to address is, what are you getting in? What standard do you need to filter it to based on that machine's requirements? How do you keep it that way? And then they had routes, as you might say, for each technician, for each area, for each machine. And I was just, I was truly impressed by that. And then one other comment is this, we hear a lot about operators doing lubes, tighten, lubricate, clean. Well, I'm not a big fan of that unless you've got an operator, say at a machine tool, with one lube and two lube ports, or, making that up. It's something really simple that each operator running that machine can do, and do it reliably and without risk of error. On the other hand, if you got 1,000 machines, 10 different lubes, a 4-shift structure, 6 operators per shift, and you're expecting operators to do lubes, well, good luck with that, that approach, because you will almost certainly destroy a few machines with that process, because they'll use the wrong lube in the wrong quantity on the wrong day, just all kinds of opportunity for error when you do that. So I'm a fan of having dedicated lubrication functions, except in, fairly uncommon circumstances. Do you have a comment on that there, Doug?
I don't think you'll have an argument with this one. This needs to be your own person, right?
Yeah.
And when I talk about a person, I'm talking about individuals. This rarely works well as a group. We can't say that all the maintenance guys are going to do lube, because generally when everybody's responsible, then nobody's responsible.
Yeah.
I hate to say that. I will also say that this is a technology that I did get level 1 certification in, and I will say I've taken a bunch of these different certification exams, and that was probably the toughest one I've ever taken. That's a very a whole bunch of detail that you need to know to be a good lubrication technician. Yeah. So folks tend to, and I know that's changing through time, and it needs to change even more. This is a specialty, and it takes somebody that's number 1, very disciplined, number 2, bright, and number 3, somebody that wants to continue to learn, right? So if you can find that person, you're going to save yourself a bunch of money. It's a worthwhile practice to say, I want to get somebody MLT certified, and we're going to dedicate that person to be the lubrication specialist for this area or this building or this department, whatever it works out to be.
Yeah. Now, one other, I may have said this earlier, but I want to make sure I've said it, and that is all these technologies need to be under the direction of a person
Yeah.
who is accountable for the application of the technology, the proper application, the proper training, the proper use of the data that comes out of them, and so on. And no matter if it's in-house or done by a contractor, that person needs to become experienced enough, trained well enough to be able to understand well enough each of the technologies so that they know that a proper job is being done. They might not know they won't be a vibration level 3 or 4 analyst. It might be level 1 in all those, but they know enough to be able to manage it effectively and use it effectively in the plant. So ultrasound, leaks and squeaks and all that sort of thing. Again, I'm not anywhere near an expert. By the way, all of these technologies, every last one of them, demands for their effective use, demands proper training and experience. It's not something where you pick up a camera and you find the guy's broken nose because you just happen to get lucky. So all of them require, I think, at least level 1 for data collection, level 2, or even level 3 for data analysis, depending on the complexity of the problem. So now ultrasound, I know you can use to find leaks. You can also use it to determine when you should lubricate a bearing, just based on the sound you're getting from the bearing. I suspect there are lots of other applications. Doug, you might know those better than I do.
This is a great tool for the electrical side of the business, for arcing, tracking, Corona. When we're looking at safe practices for opening up starter cabinets and such, or high voltage cabinets, so that we don't end up with an arc flash situation. It's the best tool, I tell companies. And in fact, very early on in my consulting career, I had a couple companies that they were interested in getting into the technologies, but they could never seem to find the money to do it. And I told them, all right, let's just we'll get somebody in here from UE Systems and have them show you what ultrasound is, and we'll go out and we'll do a quick survey of your compressed air. And if we can find enough leaks, I bet we could buy everything you need to get into vibration, IR, lube, and ultrasound just in air leaks.
Yeah.
Right.
Probably.
Now the key is after you fix them the first time, you still got to remember to go back a year later and start checking again, right? Because you're going to find different leaks in different places, and that air usage will slowly climb back up if you don't stay on top and continue to have routes. But it's a great technology for especially slow speed bearings. Works great for that. And of course, any type of compressed gas. And lots of companies waste a lot of money with that stuff, not just compressed air, but nitrogen, argon, whatever you might happen to be using at your plant. It's gonna pick that up, and that stuff is expensive. And finding leaks is easy.
And steam leaks you can find with, and steam traps, I think you can find with infrared as well.
Yeah, steam traps it works well on. Different stage pumps, 3-stage pumps. I've had good success with ultrasound on that for finding out which one of the stages is leaking by and not sealing off properly. Check valves. It was just a compressed air and even hydraulic cylinders, which ones are functioning properly or which ones are leaking by. It does a great job for that.
Yeah.
So it's a technology. I tell people it's the easiest one to get involved in. It's one I recommend for starting out with, because you're going to find stuff and you're going to save money. But I'm also a person that says, look, if you're going to get involved in this, pick those big 3 or 4 that we've talked about today, right?
Yeah. One of the things we hadn't mentioned, we mentioned, recips. There's specialized technology for that. There's, specialized technology for, for corrosion detection, for sniffers to detect explosive gases and so on. But one of the ones we hadn't mentioned that's relatively new is this vibration motion amplification detection.
Yes. Yeah.
Company out there, RDI. I know a lot of the guys over there. In fact, I used to work with some of them, and they can take a picture of a machine. They can, using their technology, they can amplify the motion of that machine. You don't have to do operating deflection shapes or that sort of thing, and they can show you how the machine is, vibrating and how it's moving in an amplified way. Such that gives you a good indication of how that machine is behaving and an indication of what the root cause of the problem might be. So that it's really an impressive technology, so I'll put in a plug for those guys. It may be a little more specialized because you probably don't need that in some cases if you just align and balance your stuff. But if you got a resonant problem or, some sort of interaction problem amongst your machines, then probably be a great technology to kind of help you pinpoint that. So, Doug, do you have any comments on that?
Yeah, it's I call it they've called it vibration for dummies, right?
Yeah.
Because lots of folks have a hard time understanding what vibration looks like, what misalignment looks like, what looseness looks like. Yeah. And when you put that motion amplification in front of them, they go, holy smokes, that looks terrible, right? Yeah. And you realize, well, it's really kind of a magic with pixels, right? It's not really moving as much as it looks like in that video that you're watching there, but that's what misalignment looks like. All right, that's what that looseness looks like that we're talking about. And if you don't do something about it, you can see it's going to damage things, right?
Yeah.
So.
Yep. So, well, one thought on that, Doug, you just prompted. I do a little, 5-minute skit on vibration analysis, and it's really quite straightforward if you give it any thought at all. But if you have an unbalanced machine, you've got a heavy spot on one side of the shaft, right? So as that machine rotates, you're going to get a little thump of energy. So thump, thump, thump. So every time that heavy spot passes your sensor, the sensor gets a little jerk. And so that's occurring at what frequency? Well, 1 times turning speed. And if you got a misalignment, you got a shaft that's coming in that's offset, maybe at an angle. And as that shaft rotates, you're going to get thump, 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 thump. And so that means that sensor is going to twice per revolution, or 2 times turning speed, you're going to get a little thump, 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 thump.
So if you're going to 1800 RPMs, that's 3,600 thumps per minute.
Right. And of course, ball pass frequencies, inner race and outer race, you can calculate those. And so if you've got a defect in the race or a defect, and then you got the ball frequency, so if you got a defect in the race, as that ball comes around, each one of them, it gives a little ding. And so you get a ding, a ding, 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 or a ding, 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 at a higher frequency. And you can calculate all that, and then you set up your frequency bands to pick up on those, and then you measure the change in that, in that amplitude of that machine, and then you've got a good handle on, is it getting worse? Is it getting better? That sort of thing. So just remember that, that thunk, 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 and the ding-a-ding-a-dings. And if you do that, then you got a pretty good handle on it.
All right.
Looseness is just lots of side bands.
So
Everything's vibrating. So, okay, enough said.
we're getting close to our time.
Yeah.
And I know you're the right person to ask on this. In terms of our listeners, are there a couple good books out there on these technologies that you say, hey, if I'm looking to get started here, here's a couple things that I'd sit down and read before I went and talked to anybody?
Well, I think probably the best book on vibration I've seen is Art Crawford's.
Mm-hmm.
Art, sadly, Art, wonderful, wonderful guy. He's gone now, but Art Crawford wrote a book about vibration analysis, and in my view, that's the world standard. So now there may be others. I just happen to know about Art's and have an incredible amount of respect for him, and I'm sad that he's gone. The others I wouldn't really know on oil analysis and ultrasound and so on. So I'd have to defer to somebody else. I know Drew Troyer. I don't know if he's written a book about oil analysis. I know he's really, quite good at it. And there's
probably 500,000 articles.
Yeah.
Yeah.
So he would be, Jim Fitch is another name that comes to mind. I haven't seen Jim in decades now. Let's see, on infrared, gosh, you got me. I don't know if there's a good book out there on infrared. Probably is. One resource to ask would be somebody probably in Terry O'Hanlon's organization. And he's got lots of books that he publishes. So, you could go check to see if he's got any that would fit the bill. And of course, you can always Google.
All right.
So, all right. Are we done? We didn't have any questions. I don't know if we just confused everybody or we didn't know enough to prompt them to ask questions. So, all right, guys, let's see.
I think you guys covered it all.
Well, I've got a bunch of notes I scribbled before we started. Let me make sure I've covered everything. Well, one other thing that you probably good to understand. I've got some data. I always have data that if you have a good vibration monitoring program that covers upwards of 80-90% of your equipment, and you have good work management, and you're proactive, then your costs are going to be dramatically different. But if you're not monitoring much of anything, then your costs are going to be dramatically higher. And the second data says, well, if you've got, if you're doing all PM, you're doing time-based, particularly time-based intrusive, you're going to cost yourself a small fortune that you don't need to. And you're also going to take the equipment down when it needs to be producing. And it's just, being dominated by time-based intrusive maintenance is really a bad idea. You ought to do things based on condition.
Okay. See, we do have a question.
What criteria?
Other than criticality, what criteria do people use to include assets in a program for vibration?
Well, if criticality includes consequence of failure and failure mode, I think that covers it, Doug.
Well, he's saying other than that. So I'm going to tell you cost. So what's the downtime costing you versus the cost of performing the task? And when I was preparing estimates for another company that used to do this, I'm trying to remember how many data points they would do per hour. And I want to say it was 12, right? So number of data points times whatever the hourly cost is for vibration analysis, and then the cost of what your downtime is if the item fails, plus the cost to repair it. So it doesn't take that much thought to say, gee, if this motor fails and we're not using vibration analysis, we're going to have X amount of downtime because it's going to be a surprise to us. And then we're going to have to figure out how we're going to get the parts. And you're going to have ruined the motor, so we've got to buy a brand new motor. And then Okay, if we had vibration analysis, it would cost us X dollars per month to monitor it. And if we were to detect a failure, plan, schedule, the downtime would be less, and we could repair the motor or do a rebuild on it. So we're not having to buy a whole brand new motor. So use those cost comparisons to say, this is worthwhile.
I would imagine, though, wouldn't criticality include consequence and therefore cost?
It should, if they've done a proper job of doing it.
Okay. All right. Well, I hope we've answered it, guys. We're running out of time, but if you do have questions, you can send them to Kim and she'll get them to us and we'll do our best to try to answer them. I know this has been a real high level, touching the high spots, but I hope you've gotten some benefit out of it and that you'll take this back and start to use it. So, Kim, are you going to sign us off at this point?
I am. Well, thank you both so much for another great conversation.
I'd like to wish everybody a happy holiday.
Yeah.
Yes. Happy holidays to everyone. They're sneaking up on us.
We
I have a feeling.
are not going to be around in December. So if it's Hanukkah or Christmas or Kwanzaa or whatever you're celebrating, enjoy your holidays, and we will see you in the new year.
Yeah.
Yes.
I do Christmas. So Merry Christmas to everybody and Happy New Year.
Merry Christmas to you, Ron.
All those other things. Yeah.
Oh, thank you guys for your time as well. Just a quick reminder, since we are taking December off, everyone, all of our past, I'm going to say 15 episodes are up on YouTube under Mobius Connect. So go check out Mobius Connect's YouTube channel to see all the past episodes, and follow us on MobiusConnect.com on all of our social media. We will be back in January, so remember to keep checking out Reliability Connect to see the next episodes and register. Again, we hope you guys all have a fantastic holiday season. Thank you for joining us. Have a great day, stay safe, and we will see you in January.